Hello class. Today we're going to be talking about surveys and cardinal numbers. And I'd like to start by just remembering this word cardinality. The cardinality of a set, or the cardinal number, is the number of unique elements within that set. So, what is the cardinal number for A union B? Suppose that this is my universal set, this is set A, this is set B. What could I use to show the number of elements in A union B? Well, the cardinal number for A union B is the number of elements in A plus the number of elements in B. Now, if I left it like that, just the number of elements in A as well as the number of elements in B, I would have everything here plus everything here. But what would happen is this intersection would end up getting counted twice. This A intersect B belongs to A and got counted there, belongs to B and got counted there. It got counted twice. So to adjust for that double counting, we have to subtract the number of elements in the intersection. So let's suppose that set A is talking about, let's suppose set A is the group of people who ski, and set B is the group of people that know how to snowboard. So if you know how to ski, you belong to set A. If you know how to snowboard, you belong to set B. If you can do both, you belong to the intersection. Let's also suppose that the number of elements in A is 15. The number of elements, whoa, can you see that? Let me zoom that out a little bit here. There we go. Okay. So the number of elements in A is 15. The number of elements in B is 20. And let's suppose that 10 people can do both. And that the universal set, oops, let me write that differently. The number of elements in the universal set is 30. So 30 people were surveyed. 10 said, yeah, I know how to ski and snowboard. 20 people said, I know how to snowboard, and 15 people said, I know how to ski. Well, if we want to show how many different elements are in each portion here, I'm going to start off with the intersection, the most specific piece of information. There are 10 people that can ski and snowboard. My intersection has 10 elements in it. The number of people who know how to ski is 15. So what that tells me is that all of A has 15 people in it. Well, 10 people have already been put in there, right? So how many more do we have? We have 5. The number of people who know how to snowboard is 20. 20 people can snowboard. We already have 10 people in set B. So the other 10 are going to be here. And so just to recap, so far I have 15 people in set A, 20 people in set B, 10 people in the intersection, The universal set is 30. How many more people are there that don't ski or snowboard? Well, that would be, what, I have 10, 20, 25 people. That means I have 5 people who don't ski or snowboard. They don't belong to set A. They do not belong to set B. Let's do another example. Number of elements in A is 19. Number of elements in B is 13. Number of elements in the union is 25. Number of elements in A prime is 11. So here's my universal set. Here's set A. Here's, do we need intersection? Yeah. Here's A intersect B. Here's B. Well, I know that 11 people are not in A. So that's B and the universal set. I know that 19 people belong to set A. And what I want you to do is go ahead and play with this for a minute. I want to write down the formula first, though, just to kind of give you a little guidance. And then I'm going to, well, I don't want to just sit here quietly. I'm going to have you pause this and just play with this for a second. And I'm going to use this cardinal number formula that we have up here. Number of elements in A plus number of elements in B minus the intersection is what we get for A union B. So let me just write that down. Number of elements in A union B is the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. Go ahead and hit pause and play with this, and then unpause it when you're done and see if we match. Okay, so hopefully by the time you have unpaused this, you have tried it and gotten some numbers, and now we're going to confirm. So we have this formula, right? And we were given most of this information. The number of elements in the union is 25. The number of elements in A is 19. The number of elements in B is 13. Minus, I don't know how many are in the intersection. But when I'm doing this, typically you want to start off in the most restricted environment, the smallest space, and from there build your way out. So again, I don't know how many are in the intersection, but I can solve this equation for that missing piece, right? I have 25 equals 32 minus some number. And this mystery number has to be 7. 32 minus 7 is 25. What that tells me is that I have 7 elements in the intersection. Now that I know that, I can work my way out. A has 19 elements in it. 7 are here, which means the other 12 are here. B has 13 elements in it. 7 of them are here, which means the other 6 are here. The universal set's, the universal set's not listed, but I know that the number of elements in A prime is 11. So if I have 11 elements in A prime, I'm just going to cover up A. 6 of them are inside B, which means the other 5 have to be outside of A and B. Again, I have 11 elements that are not A. Well, here's A. I have 11 elements that are not A. 6 of them are B. The other 5 are outside the circles. And then the universal set would be the sum of all of these. I'm going to have you guys play with this one, and I'll give you a hint. You want to start off with the most restrictive case, the smallest piece of the puzzle here. Well, the smallest piece of the puzzle is going to be this area. And let's say that this is A, B, C. This piece here is the intersection of A, B, and C. And there are 15 elements in that intersection. That is a fantastic way to start this problem. So again, I'm going to have you finish this, and we're going to talk about it at our next class session. And thank you so much. Have a wonderful evening. Goodbye.